So the bottom line is stress is the ultimate problem that we face if you got here with good genes. And I said 95 out of 100 got here with good genes. And stress does this. It alters the system. The stress signals come in at the cell membrane and activate the protein pathways, which are respiration, digestion, excretion, etc. But here's the issue. If a cell encounters stress, what can it do? I already mentioned a couple of things. Well, I'll tell you what it can do. Number one, it could wall itself off, go into the bomb shelter. And the question is, yeah, I can survive, but not for a long time doing that. So that's a temporary effect. It's the only thing I can do temporarily. Another thing cells can do is that they can secrete things in their environment to try to make their environment happier. But that's a very expensive process because if I can't change the whole environment, I'm always just wasting energy throwing it out. It's like trying to heat Memphis in the wintertime by opening your window and leaving your heater on, figuring maybe all of Memphis is going to get warm. And the bottom line is, no, that doesn't work either. So the third thing that is possible, now this is real exciting stuff. The third thing that is possible is you can adapt. Well, what does that mean? Well, that means change your genes or change your biology to respond to the stress. Well, what is adaptation in biology today? There is no adaptation in biology. Why? Because we undergo a belief system called Darwinian evolution that says what? That the changes in the genes, the first premise is all gene changes are random. What does that mean? How can I adapt if my genes change randomly? I don't know. Maybe sometimes they'll adapt. Maybe they won't. And the problem is this. Conventional biology has held for years and years and years the belief that when genes change, they only change by accident and randomly so that you can't ever control the outcome of a mutation. And so the consequence of that is conventional belief then talks about, well, you know those 95 out of 100 people, that, let's say in cancer, in breast cancer, for example, again, 5% of women have a hereditary linkage, 95% of women don't. Yet 95% of these other women who express the cancer alter the genes. So then what do? We go up to the chart and we say, well, the only way you can alter the genes is randomly, so it must have been just a random event. Cancer is random. Well, that's the belief system until we get rid of the assumption that Darwinian evolution is not the way that evolution really occurred, that there is another way. Well, what is that other way? It was first presented in 1988 in this paper that was published in the journal Nature. The Nature is a mainstream journal, and the article is called The Origin of Mutants by John Cairns, a British geneticist. And here's what he found. Listen to this because this is one of the most important papers in the history of biological science. Why? Here's what he did. He took bacteria that had a defective enzyme. The enzyme is called lactase. Lactase is an enzyme who breaks down the milk sugar called lactose. And that enzyme is necessary to break down the sugar to extract the energy and the building blocks so the bacteria can use the lactose as a food source to power its growth and division. So these bacteria that Cairns starts with have defective enzymes for lactase. They cannot eat lactose. That's the truth. So he takes these bacteria and he puts them in a petri dish, and the only food he put in the petri dish is lactose. Talk about stress. These little bacteria guys were going, oh man, there's nothing to eat in here. Well, the problem is this. When there's nothing to eat, they can't divide. And when they can't divide, they can't reproduce the DNA, which is generally where the source of the mutations occur. And the result is they can't divide, they can't change the DNA, we expect nothing to happen. And yet, in all the petri dishes, after a few days, there are bacterial colonies growing in every one of them. And the question was that Cairns said, how the heck did that happen? Conventional understanding says that these can't divide because there wasn't any energy, so they can't change the DNA. How did they change the DNA? So when he examined the DNA, what he found was they didn't randomly change a whole bunch of genes. They focused on the genes for lactose, the lactase enzyme, and they changed just the lactase gene, even though they weren't dividing. It was a whole new mechanism, a whole new concept. And the interesting part about it is when he reported this, the British journal Nature, they wrote an editorial right after his paper. The editors wrote, they said, look, John Cairns is a distinguished molecular geneticist. We know his work for years, but this paper we have trouble with. In fact, the title of the editorial that the British journal had was, the title was A Unicorn in the Garden. The point is a little British humor, you know, it's like a fantasy in the Garden of Eden here, you know. The Americans, no sense of humor, because a week later an editorial came out in the journal Science, which is the mainstream journal of American science, and look at the title, A Heresy in Evolutionary Biology. What's a heresy? Well, that's for religious people. And it said this, there's a religious belief, and the religious belief, and I say religious, is that it's underlined in there that mutation is a continuous and random process. I'll read it for you because you may not be able to read it. The line underneath at the bottom, it says, Cairns demonstrated that bacteria can choose which mutations they should produce. Then the editors write, anything more heretical can hardly be imagined. Why are they so upset? And the answer is this. Think how profound it is. If mutations can occur as a result of adapting, then mutations are not necessarily random. And if mutations are not random, then evolution wasn't an accident. We didn't get here by accident. We got here by program. The relevance of this is that we actually got here through a process of creation and evolution simultaneously occurring, that the organisms were pre-adapting to the environment, and the signals in the environment were shaping the organism, so that evolution was not an accident. Well, of course, conventional religious, we went from religion, people wearing black coats, the new religion, they wear white lab coats, but it's just as much a religion as anything else. And the bottom line about that belief is that when we question the belief, everybody, what do you mean energy healing? That's heresy. What do you mean changing the genes? That's heresy. The truth is, no, it's called science. But science has a conviction to hold the truth, especially as the pharmaceutical industry, again, is trying to impress upon us because they're selling us a lot of things. So the bottom line is this. What does this say? Well, this paper, let me explain. The paper that Cairns' paper came out in 1988. That was over 12 years ago, okay? This paper in Scientific American is in 1997, so that was 9 years after. Point about this paper. I have to read it for you because you won't be able to read it. I'm going to use my theatrical. I'm on a stage, so I'm going to read it theatrically. It says, evolution evolving. Here's my theatrical part. New findings suggest mutation is more complicated than anyone thought. First line, 9 years ago, John Cairns. And the point was, new findings 9 years ago? Where have these guys been? And the answer is this. For 9 years, they consistently tried to undermine Cairns' findings. For 9 years, they did that. When this paper was published in Scientific American, they're not saying that Cairns was right. What they're saying is this. They can't seem to find another explanation, but they're still looking for it. Because the idea is, it appears to be right, but it can't be right. But now it's a few more years down the road, and now we have another understanding. So now I'm going to show you this, and this is out of Science, the journal Science. So it's not a chart that I'm making up. This is a chart out of the journal Science. This is the flow chart of information before Cairns. This is the Darwinian flow chart. How does it work? It says organisms at the top mature and they mate. They create variants. So let's say two dogs. Two dogs at the top mate. They make a litter of puppies. The puppies are all variants of the parents. That what happens is, we also know there's a runt at one end of the litter and there's the bulldog one at the other end of the litter, so there's a range. When the puppies have to leave the litter and they have to go out and fend for their own lives, what's going to happen to the runt? Is it going to make it? No, it's not going to be able to survive. It won't be able to compete. So what happens is nature selects the strongest one to survive and gets rid of the weakest one. That's what selection is all about, natural selection. So it says this, that those that are capable of surviving mature start the cycle over again, that all the variations arise in the part of the reproduction phase, which is the belief is when the DNA gets altered. Now, I'm going to show you the new flow chart based on Cairns, and it becomes very relevant for this reason. Let me first explain it before I show it to you. You see the box variants? I'm going to show you in the new chart, it's on the right-hand side, but there are 3 variant boxes. So it goes organisms, variant, 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 selection, and I want to talk about those first. So let's take a look at the chart. The chart is this, organism, and there are 3 variants, genes of DNA metabolism, genotype variation, phenotype variation, selection. Let me explain what they represent. Phenotype variation. Phenotype is the physical expression as you see it. So your phenotype is how you look physically in the world. Genotype is the underlying genetic code that programs for this structure. The box on the top, there's a new name for it. So let me give you the new name because it makes much more sense. The box on the top is not called genes of DNA metabolism anymore. There's a new name. It's called genetic engineering genes. What did they find? That in every nucleus, in every cell in your body, you have genes whose function it is to rewrite the other genes if they encounter stress. So the significance is then you're capable of rewriting your genes. But here's the most important part. What was not even included in the other chart but is now included, and it wasn't there before? And the answer is these two boxes right here, the environment and organisms' perception of the environment. Look where the arrows go. What can the environment do? Follow the arrow.